Hey folks, thanks for checking out this presentation. I'll be talking about body layers, a toolkit we built for body-based augmented reality. But for starters, let's look at the general issue we are tackling here. As I just said, we want to do body-based augmented reality. At this point you might wonder what that is all about. But before we get there, let's quickly recap what augmented reality is good for in general. Roughly, it allows us to place virtual content into the real world, like this object here. That's useful for helping with maintenance, looking at furniture, or playing games, just to give a few examples. There's been a lot of research and tracking and rendering to support this. But unfortunately, tracking in augmented reality right now really just means tracking of markers on objects. Yet what we were interested in was to build augmented reality applications that focus on augmenting people. So instead of tracking markers, you might want to track bodies and faces. Now, you might ask why you would want that. So let me give you a few really basic examples. You might want to show name tags on people you meet. Maybe you want to see who talked how much in a meeting. Or you could want help with figuring out the emotional state of people you talk to. Fortunately, there has been a lot of progress in the technology that enables this. We have better and better face and body tracking, and also much better models to recognize people and infer some information on them. So for example, now you can get the age or the gender inferred of a person. It's also gotten much easier to display content on and around bodies now. For example, with face masks or virtual makeup. You might have seen Instagram filters like these here, for example. Unfortunately, while the technology is available, it is not easy to actually prototype such body-based augmented reality applications. What are the main problems right now? Well, first of all, a lot of the technology for tracking and augmenting faces only works on phones and is limited to the front camera. So you can design new selfie experiences, but you can't really use that stack right now to prototype apps that augment a conversation or maybe a meeting. Furthermore, if you use an API to kind of build all this stuff yourself, the barriers of entry are high and it requires a lot of expertise as well as money to build these applications. In the paper, you can also find this table where we show an overview of the current tools. Check that out to get a better idea of what's available, but also what the limitations are right now. So we set out to create a tool to address these limitations. We wanted something that allows non-experts to prototype body-based augmented reality applications in a fast and easy way. So we built the Body Layers toolkit. Let me walk you through it. Here we see the main view of the Body Layers editor. There's a big canvas in the middle and a drawer on the left side that shows all the available nodes. Users can drag nodes from that drawer to the canvas. We already see that the user created 3 nodes at this point. We have a number node, a face tracker node, and a script node. Nodes can be connected by dragging from the output point to an input point of another node. Here we can see that the user changed the number to a specific value, and the number now is used in the script as an input variable called speed. Here we just paste the script in. What this script does is essentially just outputting a rotation value. But now let's turn our attention to the actual face tracking and recognition. We already have a face tracker node in the scene, and that will output face values. That's a complex type, and what we can use the face property node to access individual properties, such as the position of a face. We now also added an emotion detection node to the scene. That, given a face or other information, detects emotions. Now, emotion can also be something much more complex. For example, we could have ratings for a number of different emotions. Here we use an emotion operator node to extract the most confident emotion. So this will give you a string such as sad, happy, or any other kind of emotion you can recognize. In this case here, we want to detect whether somebody is happy. So we add a string node to the scene as well as a compare node. We can use the combination of the string and the compare node to check whether the most confident emotion we got from our emotion operator node actually is happy. As I said earlier, we actually want to show a model depending on the emotion we detect. So now we're going to add a 3D model node, and as you can see, it has a number of inputs. The first one we're going to be using is the show input. So if our compare operator is true, meaning that we detected a happy emotion, the model will be shown, and otherwise it will be hidden. We're also using the orientation input, and we connect it to the rotation output from our script. So that just means that the model will spin around. Now, we also want to place it in the world, ideally atop the detected face. We can use the hover position node to kind of just add a little bit of a vertical offset to a position, and we just connect it to the position output of the face we detected. Because the model we're going to be using is rather big, we also use the scale input, and we add a number node where we can set a slightly smaller scale for our 3D model. And finally, we want to give a color to our model. So we also add a color node, and we connect it to our model. The model we're going to be using is one of a happy little sun. So to kind of show how happy it is, we're also going to be picking a bright yellow color to go with it. And of course, we also need the actual model of the sun. We can find it in a folder, and we add it to the scene just by dragging it onto the 3D model. If we now play this, you can see as we sit down in front of this happy person, a floating happy little yellow sun appears on top of their head. Let's take a step back here. As you saw, the toolkit itself is designed primarily for flow-based editing. Users thus don't need programming skills and can create applications just by connecting together a few nodes. But more experienced users can also write arbitrary JavaScript for more complex actions. And I should say that, in fact, the whole toolkit is built in JavaScript, and all the nodes are mapped to JavaScript code as well. For interfacing with actual devices, we defined an intermediate BuddyLayARs API. In application, this is really just a bundle of assets and JavaScript code. Right now, these bundles can be run in a host application on the HoloLens and a desktop application that we built. But we hope to extend this in the future to other devices as well. You can start applications directly from the editor on connected devices and also change these applications while they are running. So you can, for example, change the color of a model or tweak the position of a label as your application runs. This allows for faster iteration times, much faster than the usual compile and deploy cycle. In our paper, you can find several example prototypes we built using BuddyLayARs. Also check out our video to see some of these in action. BuddyLayARs is open source, and you can download it and try it out yourself right now. I should also mention that we very much designed this to be customizable and extensible. If you know JavaScript, you can tweak the existing nodes as well as create new ones. That includes the way the nodes look and behave in the editor as well. We really see BuddyLayARs as a first step in making body-based augmented reality more approachable. Right now, what can be tracked and rendered is still rather limited, but we hope that this can be extended in the future. For example, we'd like to have virtual makeup and other kinds of face effects. We think that body-based augmented reality can create a whole new set of exciting new use cases, where people's interactions with each other are augmented. Instead of engaging with virtual content, we are then engaging with people, but with additional layers added to those interactions. With BuddyLayARs, we make prototyping of these experiences easier, and we hope to inspire others to also design augmented reality for more interpersonal interactions. I hope I've given you a good overview of BuddyLayARs. You can grab it right here. And feel free to reach out to us if you need help getting started or if you have any further questions.